Hello friend, welcome back to the session. We have been working on this question. Okay, the question says a pair of fair dice is rolled and its outcomes recorded. Find the probability that the sum of the two numbers showed up is at least 8, at most 10, exactly 7, exactly 1. The probability formula is this one, that equals number of events over divide of number of sample space, that how many elements are in sample space. So according to our diagram, this one here, we counted the sample space there. In sample space, there are 36. These ones, there are 36. So now we shall be calculating the events for the others. And now the first one, that is part A, says at least 8. At least means from 8 going upward. So 8 is this column. Okay, can you see moving along this diagonal? That's when you find 8. So along the diagonal, there are 1, 2, 3, 4, 5. Okay, so since it is at least, then this is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I'm getting 15. That is for part A. Let me write my answers here. For part A, I'm getting my event as 15. Okay, remember the sample space is 36. Then for part B, let me first summarize my answers here, then we shall work out the probability. For part B, at most 10. Okay, where do we get our 10? Our 10 are these ones. Remember, at most means from 10 going downward. So we have this. Okay, we have this. Then we have this. That is 10. Then we have another one. That one also gives us 10. At most 10s from this diagonal going that side. Since that side has got very many numbers and above 10 there are very few, then let's count those which are above 10 to simplify our work. So above 10, I can see there is 1, there is 2, there is 3. So there are only 3 events which are above 10. So 36 minus 3, here we shall get our events as 33. Okay, yes, we shall get our events for B as 33. Okay, then what about C? What about C? C, we have exactly 7. Exactly 7. Where shall we start? Start with this one. Okay, this one is 7. That one is 7. This one is 7. This one is 7. That one is 7. And that one is also 7. How many are they? 1, 2, 3, 4, 5, 5, 6. Okay, I'm getting 6. There are 6 events. Then for part D, exactly 1. Look here, that when you add 2 numbers, you get 1. In this table, they're not there because the first part in our table, the first column, the first row is this one, where we have 1 and 1, of which when we add these 2, we are getting 2 and not exactly 1. So what does it mean? In this one, our event is 0. That does not exist. Now, this is how we calculate the probability now. So for part A, at least 8, we got 15 events. So probability of getting some at least 8 will be equal to number of events, that is 15, divided by number of sample space, number in sample space, that is 36. So simplify by 3, this is 5 over 12. So get the probability of getting some at least 8. This is what we can have for our answer. Then solution B for part B, what does it say? At most 10. At most 10, there are 33 events. There are 33 events. So probability of getting some at most 10. getting sum at most 10 equals number of events, which is 33, divided by 36, which is your sample space. Okay, divide by 3, this is 11, this is 12. What about solution C now? What does solution C say? Exactly 7. Exactly 7. Exactly 7 has got 6 events. Therefore, probability of getting sum exactly 7 equals number of events, which is 6, divided by number in sample space, which is 36. Okay, by 6, 1 over 6. What about the last one? That is part D. Exactly 1. Exactly 1. That event is not there. It is 0. So probability of getting exactly 1 equals number of events, that is 0, divided by 36, which gives us 0. So in other words, the probability of getting sum of two numbers which showed up equals, at least 8, we got 5 over 12. At most 10, we got 11 over 12. Exactly 7, we got 1 over 6. Exactly 1, we got 0. That probability is not there and does not exist because it has got no events. Thank you for watching. Looking forward to be with you in the next session. Welcome.